Hello, welcome to Stream Analytics on Manning Publications, Twitch. My name is Richard Nuckolls, and I'll be your host today. So we're going over creating and configuring and running data through Stream Analytics service in Azure. So thanks to Manning Publications for sponsoring this Twitch today. This is supporting my book, Azure Data Engineering, which will be available this summer in print and is available right now on the MEEP Early Access Program through Manning.com. Today we're going to be talking about some of the highlights of Chapter 6 of the book. Chapter 6 being on Azure Stream Analytics, a service for handling analytics with streaming data in Azure. If you want, you can see the site at Manning.com. And I think we're going to go ahead and jump right into it. All right. I went ahead and created several other support resources that you'll want to use when you're running Stream Analytics in Azure. So Stream Analytics is a service in Azure which supports doing analysis in near real time on streaming data. You've got multiple sources you can use, but they are very tightly integrated with Stream Analytics, those being Event Hubs, Blob storage, and IoT Hubs, which is really a subset of Event Hubs. So I've set up both a storage account and an Event Hub to support today's streaming session. And I've got some data prepared so that we can run through some of that with you. All right, first thing we're going to do is just get the Azure Stream Analytics service set up. There's several different ways to set these things up. I'm just going to use the Azure portal here because it's pretty easy to do, and it's a bit more visual for those of you watching at home. Multiple ways you can get to it in the Azure portal, of course, and setting up a Stream Analytics job is something we go over in Chapter 6 in the book, Azure Data Analytics. So I use a naming convention for the resources that I set up here, and that's covered in the book as well. It's basically covering from broadest to narrowest the various aspects of this, what this service does, starting with the region, moving into the application use or the system that it's running on, the environment, and then the type of Azure service that it is. And then if you've got multiples of that type, you can run suffixes to show those various differences, and then also ending with a number. But in this case, we're using demo. I'm going to say this is the prod environment, and what we're setting up here is Azure Stream Analytics. I abbreviate that as ASA. You could call it streaming, call it stream, call it job, stream job, if you like. I've got a couple of subscriptions, so we're in the pay-as-you-go-to subscription here. If you've worked with any of the Azure services in the past, you know that we've got requirement for a resource group for every service that you set up. So I've already set up the resource group East US Demo Prod RG. So that's what we're going to be using here, putting all these other services to support this in the East US region. And you can see that's it's part of the naming convention already, so it's easy to keep track of where all these services are and should be. Stream Analytics does support 2 different places that you can run the job, so that you can actually do processing of your streaming data out on the edge in your IoT device or your IoT gateway device. For this purpose, we're going to be running them in the cloud, which is in the Azure cloud, so that we can use a bit broader set of data here. But one of the things you do get if you do choose to run the Stream Analytics on the edge is a direct and low latency connection to that IOC devices that are streaming to your gateway. Like I said, we're running in the cloud here. You can set the number of streaming units based on how much data and how many different calculations you're intending to run, the complexity of the calculations, and how much complexity you can get out of them. Today, we're running a fairly small set of data through here, nothing that our Stream Analytics engine and the Event Hubs endpoints can't handle at the lowest setting, so we're just going to be using a single streaming unit. Multiple streaming units come into play once you've got more than one parallel source for your data. If you are targeting blobs, which we'll see later here, you can have multiple files being read at the same time, while if you've got more than one streaming unit, and the same goes with the Event Hub, if you've got more than one partition, of course we'll have 2 partitions at least with Event Hubs, but if you've got multiple partitions and you're using partition IDs to separate the data that's coming in for higher throughput, then you want to scale your streaming units up to match what you're pushing in from, or what you can pull from Event Hubs. But in this case, we're just running a small set of data through here. A small set of data through here. So a single streaming unit will be just fine. If you wish, you can secure your data assets here in a storage account. This provides a bit more security over your configuration files, but they're already managed pretty well and securely in the background with Stream Analytics, so it's not something you're required to do. So the configuration files are secure, but this gives you more security at rest for your data elements while they're in flight. So we've got our Stream Analytics job set up here. Go ahead and go take a look at this. So this very easy to get one set up and running. Now the tricky part is, how do you configure it? That's actually one of the nice things about the way Stream Analytics is set up in Azure. Several of the services that Microsoft has set that are more on the proprietary nature are featuring really tight integrations with other services. So they actually are easy to configure, easy to connect, and communicate with each other really well. Now that we've got this set up, as I said, I set up a couple of services in Azure earlier to support running the Stream Analytics. One of those is Event Hubs, which is a high throughput journaling message event endpoint. So you can run lots and lots of data through the Event Hubs endpoint. And once it's in the Event Hubs, you can use it for multiple other sources. Stream Analytics being a very popular one, but you can, of course, have Event Hubs triggering Azure functions, logic apps, and multiple other endpoints, including your own custom code. I've also got a storage account set up here. If you are using file-based data and you're generating file data on a regular basis, then you can drop your files in here, point Stream Analytics at a Blob container. And Stream Analytics will pick up the Blob files as they are modified and added, as they are added into the Blob container, and then read them as stream data into the stream. It's the way to have many batches running through a single stream conduit for doing your analysis in real time or near real time. So now that we've got our Stream Analytics job set up, we've got our input sources. We also want to talk about output sources, where we have a limit of just 3 types: the Event Hubs, IoT Hubs, and Blobs. For the inputs, we have quite a few more outputs that we can write to. We can write back to a different Event Hubs endpoint. We can write to Blob storage, and we can also write to SQL databases here in Azure directly. There's a few other interesting things like service queues and service bus topics directly out to Azure Functions as well, if you need some type of programmatic handling of specific sets of data that come out of your Stream Analytics. We're going to talk about both blobs and SQL databases here. And I've also got a SQL database set up for use both in reading and writing. So we'll get to take a look at those things now too. If you're just joining us, my name is Richard Nuckolls, and this is setting up Stream Analytics in Azure on Manning Publications. We're supporting or promoting my new book, which comes out this year. It's already out for Manning Early Access program, Azure Data Engineering, which covers many technologies in Azure that you can join together to form a data analysis system. All cloud-based, all scalable, and pay on demand. Today, in particular, we're talking about Chapter 6, which is real-time queries with Azure Stream Analytics. So if you want to follow along, if you already have the live book version of the book, you can look in here. I'm not really going to be actually following along. We are going to be picking and choosing some of the code from in the book, but mostly we're just going to be going along, showing some of the tricky parts here. As easy as Microsoft has made setting up services in Azure, there are still some complicated bits and some bits which can frustrate you or just take a long time to get set up and working and understanding. So I wanted to talk today about what I think is one of the more complicated ones. All right, we've got the Stream Analytics job set up here. You're familiar at all with it, you know you've got inputs, outputs, and a query that joins them together. By default, your query selects a couple of placeholder inputs and outputs. One of the really nice things about Stream Analytics is the query is written in SQL with a couple of extra keywords or commands, function calls that you use to configure the streaming nature of the query in the Stream Analytics service. We'll go over that a little bit later. So we've got our query here. We've got no inputs currently, but on the input screen is where you can see and add inputs to your Stream Analytics. So this is where you should start. See, we've got two types of inputs you can add. You can add in the regular stream data stream inputs. You can also add in reference inputs, which are static data that you can load up from different sources, Blob storage or SQL database, and enhance the data that you get in your data stream. In general, your reference inputs will be used with a join in the query to the data that's in your stream input. So let's start off with what could be an easy input, could be a tricky input. All depends on if you've got your data set up and what you have for your timing. So all of the inputs need an alias, basically a name, so you can identify them in the query. And because the query uses both inputs and outputs, I find it's beneficial to prefix both your inputs and outputs with a notice that they're either in or out. Let's see, so this is an input. We're going to be running this from Blob storage. Call this stats. I've already set up a few files here, and we're calling this data stats coming in. So as you can see, we've already got pretty good integration with Blob's services here in my Azure subscription. Pay-as-you-go number 2, it's already selected in the drop-down here the storage account I set up, which is East US Demo Prod Store, and already pre-populated securely the storage account key. So I've got access to the storage account now. If I needed to, I could create a new container to run this input off of, but I've already created the inputs that I want to use, or the containers that I want to use for the blobs. Stats input being the container we're going to use. Show you that over here in the East US Demo Prod Store storage account. Got these 3 containers here, and I've already added in input1.csv in the stats input container. Pretty small file. We'll take a look at where our contents are here. Nice thing about working with text files in the Azure portal is that you can, in general, browse and view them in the window. So this is just a very simple set of data in the CSV format. We've got a header row here so that we get friendly field names in our query. And then we've got 4 fields here in some standard formats. Stream Analytics will actually read and do a best guess application of file types or field types for these. And here we have a date time in, let's see, I think this is ISO 1801 or 1806 format. A couple of integers and a text. Could be varchar, could be in varchar. Not sure what Stream Analytics use in the background, but I'm pretty sure it's going to be a text-based variable for that field. So now that we've looked at that, it's called input 1. We might want to know what the folder structure is like in our storage count blob container if we've got something other than just drop it in the root folder. In this case, it's pretty simple. It's in the root of the container. But if you do have it in folder structures, you can modify your folder structure so that you can input a path here so that it matches your folder structure in the blobs container. One thing to keep in mind is that if you do have folders, start with the folder name. If we had a folder called stats, start with stats. A leading slash on there will actually look for a kind of a weird pattern. So start without the forward slash. One of the things we'll see here in our outputs in a minute is the date formatting that Stream Analytics can automatically apply to your file names. Because Stream Analytics is handling an unbounded stream of data, or an unbounded set of data, the idea of time actually plays a big part in pulling data in and exporting data out, sending data out, and Stream Analytics has made it pretty easy to separate or generate new files while you're running the stream. This pop-up, which you can't see on your screen, talks about, there we go, maybe you can get it on there, talks about adding in the 2 variables that go into the path. If you want to use them, you can use the date and the time variables and choose a format that you want. If we want to use YYYY/DD/MM in this path pattern, it means we're going to end up with a stats/year/day/month/ then time, but the format will be hours, long hours. Said this is actually an input, so we don't need to check the input pattern or the path pattern for anything other than a file in the root here. But if we wanted to keep separate files in here and only run ones using input name, we could actually put input. I think input star works as well for matching those. The last thing we need to configure for our inputs is the type of file, basically the file encoding that we're using, serialization for this file. We've got a few different options. The easy ones to use are Avro, Json, and CSV. The other ones require a bit more configuration and messing about to get them to work. Json does work. It's a little bit trickier for deserializing arrays that are subsets or sub elements of the top. But as we saw before, this file is a CSV file, so we're going to be using CSV as our encoding for this file or serialization format for this file. We're using commas, but you can have what's effectively a CSV or a TSV, semicolon, semi-SV, with various types of delimiters here. We're using comma. UTF-8 is your only option, so if you're not using UTF yet, you should probably move away from ASCII to something that's more Unicode friendly. And finally, you can actually use gzip or deflate to keep your file sizes down in whatever storage endpoint you're using. In this case, blob storage. We're not using any compression on these, so we will keep that at none. All right, we'll save that. So the input has been created, and now Stream Analytics is doing a test to see if they can connect, see if the Stream Analytics service can connect to the blob, see if there's a file available there. So we've got this set up here. I want to draw your attention to the right hand, the right end of these. If we need to, we can run the test again from here. We can delete the input at this point, but probably your most important button to ensure that you've got your input set up correctly is this sample data from input button. So I want to spend a few minutes on that. I'm gonna break for channel identification. Thanks for joining us, Manning Publications. This is Stream Analytics on Azure, and talking about Chapter 6, Real-Time Queries with Azure Stream Analytics from my book, Azure Data Engineering. So thanks for joining me today. My name is Richard Nuckolls, and Azure Data Engineering coming out in print later this year, and we're already available in the Manning Early Access program on the Manning.com website. We just released the last chapter this last month, and it's very exciting. We're heading into production pretty soon. So if you're just joining us, we have created various services to support a Stream Analytics pipeline, and we've just finished creating the Stream Analytics job service in Azure and setting up our first input here. This input is a Blob input using a file that we have here in a Azure Storage Account blobs container. So the trick to sampling data and making sure that your input is set up properly with a blobs input is modified date. Stream Analytics, when using inputs from blobs, use the modified date to check whether the blob has been imported before. So doing this test, you'll actually want to make sure that the modified date for this file that's in the folder, one or more files that's in the folder, falls within the range that you're testing for in your data sampling. So in this case, this file uploaded at 3:49 p.m. Eastern Standard Time today. So we want to make sure that the range that we're testing for and sampling for contains 3:49 p.m. As you can see, the default here was about the time that I set up this input. I actually want to set that back to an earlier period, and then we can test for a particular duration with this window. 3 minutes is the default, which hopefully should get you a small chunk of data. If you've got a large thing, you'll grab basically 1,000 events or a megabyte worth of data out of here, or all of the data that comes in through this streaming window. This is one of the first times we're looking at a windowing function for Stream Analytics. So we are going to read data that has a timestamp between 3:38 p.m. today and 3:42 p.m. today. We'll grab 3 minutes and we'll see if this works. This can take a minute or two to run. Sometimes it takes 3 minutes, the whole duration that you've run. Sometimes it will find it very fast. If it finds the data very fast, then it usually comes back pretty quick. Otherwise, it may come back with can't find any data. But this is one of the reasons I felt this was a strong candidate for streaming, because this is one of the more tricky things to get set up and tested and to figure out why is it working or why is it not working. While that's running, I'll take a break. All right, no data. So it says it didn't pick up that file that was already there. It didn't see either because the modified time wasn't in the range, or something else. So let's go ahead and upload a second file. So why don't we do we're going to do another sample. We've got 4:35 p.m. here. Let's leave 3 minutes on there. Make this 4:34 p.m. Start that sample running, and let's upload a file. Here's input 2. Upload that file. We've got 4:35 p.m. 30 seconds. And again, no events found. Well, let's try this one more time. Let's put this at 3:49 p.m. Let's run that window 55 minutes. Let's see if we can get one or both of those files now to pick up. All right, so this time we finally managed to get that window to match. Either I've got the wrong dates in there, the wrong windows. It's not reading my time on my local machine the same as it is in Azure. But this time we were able to sample the data in there. The input 2 here. We've got 5 rows data there, same for input 1. All right, let's see if we can open this downloaded file up here. And here we go. We've got, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rows here in the captured file. So it captured both files that time, pulled them in, and wrote them out to this sample. So we know that that input is running properly, and we've got data that can be read there. Now we've got a working input there. Let's see what it looks like to create a working output. As I said earlier, we have multiple outputs, more outputs than we have inputs for Stream Analytics. But these are some of the things you can get this tight integration with Stream Analytics with. We've got Event Hubs and SQL database and Blob storage. You can actually use table storage and write this data out to a table. Service bus topics and queues. Cosmos DB, which is a large scale or global scale, you could say, document database. Power BI, you can actually wire this up to a Power BI dashboard and get real-time updated dashboards with data coming in through Stream Analytics. Of course, you do have a limit on how fast Power BI will refresh that data and how much data it can take in. So if you've got a huge fire hose of data coming into your Stream Analytics, you don't want to throw all the raw data there. You want to really manage a tight set of the most important aggregate data that you'd be running off to Power BI. And Data Lake Storage Gen 1. which is what one of the services I talk about in the book as a target for a lot of data. Azure Functions and Azure Synapse Analytics. Azure Functions for programmatically handling events. Again, you probably don't want to have a fire hose of data coming out to Azure Functions because they won't be able to handle that much, even if you spin up quite a few on-demand functions in parallel to handle it. Azure Functions will read a batch out as well, but you'll want to make sure you've got an aggregate of data or a lower rate to run out to Azure Functions. Synapse Analytics is the revamping of SQL Data Warehouse in Azure. So this would be a sort of an equivalent to SQL Database as an output, and it's something you could write probably an aggregate data set out to for later querying. So we've got a couple of outputs here. Tell you what, blob storage is the simplest, so let's start with that. Since we've already seen the data coming in, we can see the data coming out. So, said, good to have outputs prefixed with out, inputs prefixed with in. This is blob output, and this is stats data. One of the things you'll see later in the query section is you can have multiple inputs and multiple outputs and mix them together and output a single data source into multiple data outputs. So you actually may run a single job to two different endpoints with your outputs. Let's see. So we're setting up our blob storage account. We've got our container set up already. And as with the tight integration with the inputs, you can see we've already selected the only storage account that we have here. And we have a drop down with our containers. So I went over earlier about path patterns. Here is a place where it actually makes sense to use the paths. So let's put in our date and time patterns here. So you do have a limited set of ways you can configure the path output here with slashes or with dashes. Slashes indicate when you're using blob storage that you're going to be making multiple folders or the equivalent of folders in blob storage. And as months, days, and years pass, you'll collect the data files in separate folders. I actually prefer to have multiple files collected in a single days folder. So we're going to run with this date format. So date format here feeds into the date wildcard in the path pattern. And then because we've added a slash, we've got a folder now with this format of numbers and dashes for the top level folder. And then because this is the lowest level, the time wildcard is feeding our file name. We only have one option for time format, which is long hours, so we're going to use that. And again, we've got multiple choices for our output format. We're reading in CSVs, but we can write out Parques, Avros, and Json files based on the fields that we select in the query. Just for fun, and to make it easy to read, I'm going to use comma here. Let's use the vertical bar for this CSV. UTF. So if you are interested in maintaining a larger file size, if you're streaming data out to an output in blob storage here and you don't want lots of small files when there's not much change going on in certain periods of the day, you can set a maximum time to generate a file and a minimum number of rows to generate a file. So if you knew you always wanted 10,000 rows to come out in your files, you can set that here. Also, you can set a maximum number of hours here. In this case, we are going to set new files per hour here using the time format. So we're going to collect everything that we're running in the 4 o'clock hour here. Connection string is the thing that we're using here for our connection to this blob storage, this storage account blobs container. This integration is already set up here. Talk about it in the book, more about authentication modes with managed identities. That's if you want to manage this with Azure Active Directory, it's an effective way to centralize your management and avoid having to rotate keys and such later on. So, like the inputs, we're testing the output here to make sure that we can connect, and we've got a connection here. Unlike the inputs, we don't actually test to see that there's data there. We'll actually need to find data there once we've configured our query and have started the job. All right, pause for channel identification here. Thanks for joining, everyone. My name is Richard Nuckolls. I'm doing Stream Analytics configuration setup in Azure for Manning Publications Twitch channel. I'm talking about Chapter 6, Real-Time Queries with Azure Stream Analytics for my book, Azure Data Engineering. Available in print this fall, and it's available now online with the Manning Early Access program. We just released the last MEEP chapter last month, so that's pretty exciting. Finished writing it all. All right, so thank you all for joining us, and we'll carry on with looking at setting up the query now that we've got our inputs and outputs. All right, so now that we've got our inputs and outputs, we've switched over to the query blade in the Stream Analytics job. You can see the query by default with a brand new job includes a couple of placeholder inputs and output aliases. But you can see on the left here, we've got the two inputs and outputs that we've created already. And because we took the time to sample some data, now we actually have a sample here available so we can actually preview our input. This is actually read from the file there in the blob storage. So you can see the files that are actually going to be coming in with this input. If we look at the file over here, we see that our header says player node, node value, and event time. And you can see player node, node value, and event time. Here are fields imported in this preview. Stream Analytics also adds a couple of other fields, including event processed UTC time, which is the time the Stream Analytics pulled it actually out of the file and into the stream. Partition ID, which is a partition which typically comes from the Event Hubs partition. In this case, we've got 0 for the partition ID because it's not coming from a partition source. We've got the name of the blob that was read from. We've got input 1 and input 2 here, and then the blob last modified date is reading here. This is what triggered, or what Stream Analytics used to see that this was new data that needed to be read into the stream. So now that we're looking at our query here, we've got an interesting feature for you if you've seen SQL queries before in SQL Server on-premise or in SQL database in Azure, that we normally have select from as our queries. In Stream Analytics, we've actually got select fields, field list, into an output, and then from an input. So that flips the typical query pattern that you might have been familiar with before. Let's see what that looks like with an actual working query. We've got putting these in brackets, square brackets. And capitalization and formatting isn't that big a deal. So I've actually even written this incorrectly myself. We've got into an in and from and out, so we actually need to have the in here. It's blob-stats, end with a semicolon. And we're actually into the output from the input. So you see the squiggly lines have gone away, showing that our IntelliSense is actually working here, trying to keep us on the straight, getting this to work. If you actually have this the incorrect way, we've got squiggly lines here, and we've got some IntelliSense that says incorrect syntax. Well, okay. And look at that, you can use Control-Z to undo your changes and go back to where it was before. So let's test this query. So there we go. We've got the test results from our input that we've previously sampled and set up here for the in-blob-stats input. And we've got the fields all listed here. If we want, now that we've got those listed, we could actually choose just a set of fields to output. And now you can see in the test results here that we just have these 3 fields that we specified in the output. When developing a new Stream Analytics job, I really like to start with a pass-through query, which is basically give me the input, give me the output, and let me select all of the fields and just dump them out. This actually is really helpful if you don't know the names of the fields, if you're having a hard time figuring out why your query is not working with Fickle database, especially. For blob storage, you actually generate the file on demand, so it's changing your schema for the file doesn't matter too much. It matters, it has knock-on effects later if you change your schema too often and don't change the downstream services. But for a SQL database, when you're actually writing this into a table, you actually need to match the field names from your Stream Analytics query to the field names in your SQL database table. So having a pass-through query, which is basically a wildcard select star fields query, is very helpful in the beginning. So we've saved the query. We're fairly confident that because we've got a sample of data from the input, we've done our test results, we're getting some fields out here, that this query is going to work. So the last thing to do is actually shift back to the overview blade and hit start. So all of this stuff has been testing data at rest, more or less, running through just a lightweight stream service and with just a single processor in the cluster. So actually starting the job puts this query and all of its inputs and outputs configuration into the full cluster, and we're going to run, if we're using multiple streaming units, if we're doing a lot of heavy analysis in here, then we will now be pushing this all out to the job and running the job. So the Stream Analytics job has to be started in order to actually run data in and out in a realistic manner. And once it's started, you can't configure it while it's running. You have to actually stop it in order to configure it again. So in order to start the job, this is a brand new Stream Analytics service, which hasn't been started before, so I only have 2 options for starting the job when I start the job. I can start the job now, and because we're looking at blob inputs, if I start the job now, my time is 4:59 p.m., then only blob files that have a modified date after 4:59 p.m. today will be read into this stream. Otherwise, I can start at a custom time, change the time to an earlier period where we actually might have some data, some blobs in the container with a modified date. So let's take this. This is 4:35:30 for that modified date. So this is basically setting the start time for the stream at this period of time today, and then any data that is after this time period is considered in the stream. The stream will run from then and catch up to the present moment and continue reading on until the job is stopped. starting a job takes a couple of minutes. We have to basically compile everything that's in the query, all of the updates or all of the inputs and outputs, and submit them to a cluster in the back end. One of the great things is we, as Azure data engineers and developers, don't need to worry about setting up this cluster. We only need to know how much horsepower do we need in this cluster, how much parallel processing can we run. In this case, we have a very simple query hooked up to a pretty simple input. We can actually run, if we had multiple files feeding into this, we could actually run multiple streams in here, but we're running only a single stream analytics streaming unit for this, so we're running at our lowest cost per hour for this cluster. And that's all we need to actually figure out. We don't need to figure out all of the other intricacies of running an Azure Spark cluster in the background. We actually get the benefit of writing a SQL query using a language that we, as Microsoft developers, are most likely familiar with. All right, so now our job is running. That's actually one of the trickiest parts to the whole process, is making sure that all of your inputs, your outputs, and your query are going to work, and then hitting the start button. The start button does compile all of the query into whatever language it needs to run in the background cluster. And in doing so, it will attempt to submit, and once it starts reading data, it will attempt to submit data to your outputs and read data from your inputs. And if either of those are not configured correctly, then it will fail to start. In this case, we've done everything we needed to get this to successfully start. So let's take a look. Because we've got stats output for our container, it's working properly. We'll see now a folder structure and a file output. So here we go. We've got a 8-digit year, day, month, and day, that level, and a 2-digit hour, that's level. And then we've got a generated file name here, a CSV file that was output at 5:02 p.m. today. This will continue to be updated as more data would stream into here. We can take a look at it right now. So we can see, because we started at a time after the first input1 file was uploaded to the service, to the Blob storage, but before input2 was uploaded, we read input2 in here. And you can actually take a look by going in here. You see the Blob name column. We've got input2. You might remember we configured this CSV as a pipe delimited CSV, where the input was a comma delimited CSV. So we've actually converted this file from one format to another using this Stream Analytics service pass-through query. You see that here? This is a CSV with only these 4 fields in it. All right, since we're in here, let's go ahead and add a new file. So this is a common practice. If you are running Stream Analytics using Blob storage, you're going to have files generated on a regular or irregular basis. And now that the stream has been started and is running, it has read input 2. It will no longer read input 2 again unless you stop the stream and start it again at a time earlier than this modified time. But now that we've dropped input 3 into this folder, we will see that the Stream Analytics job will read input 3, pull it into the stream, do whatever processing is required in the query, and then write it out to the output. So we're in here. Let's see if we get a nice fast turnaround on that. And here we have a new folder. This is in the 5 o'clock hour, since I uploaded that file in the 5 o'clock hour. And here is input 3 CSVs come out. And you can see the names of all of the fields that are included in the stream, including these new fields that are added by Stream Analytics. And this is input 3 CSV. So that's working as intended. All right, I'm going to stop for channel identification now. Thanks for joining Manning Publications Twitch channel. My name is Richard Nuckolls, and I'm setting up Stream Analytics in Azure. Heading into second hour here. If you're just joining us, this is content is coming from Chapter 6 of Azure Data Engineering, real-time queries with Azure Stream Analytics. Going over in depth some of the tricky portions of getting your Stream Analytics service up and running. So this is my book, Azure Data Engineering, available now through the MEEP Manning Early Access Program. We just got the final chapter uploaded last month, so that's pretty exciting. Should be coming for publication in fall of this year. Available in print. So if you want to learn more about what we're talking about today, including naming conventions using blob storage, Stream Analytics, Event Hubs, and many more services in Azure to do Stream Analytics and batch analytics at large scale, then you can pick up that book. So I have his Twitch account now, and I'm going to be putting up videos going through lots and lots of setup in Azure for all these services on YouTube. Hopefully you can find me there starting next week. All right, so we've got if you're just joining us now, we've got our Stream Analytics job set up and running. At a basic level, we've got one input using a blob container and one output using a separate blob container. And we've been able to write a simple pass-through query, which reads all of the fields from the input stream and writes them all to the output stream. We were able to successfully capture some data as tests to ensure that our inputs worked, and then start the job successfully and output new files to the output. So, as I said before, you can't modify the inputs, outputs, or query for your Stream Analytics job while the stream job is running. So I'm stopping the job now so we can add another input and another output to our Stream Analytics job. you're just joining, some of the basic things I've gone over are available in Chapter 6 of Azure Data Engineering, in case you missed out on some of the good stuff. So if we look at the inputs blade, we can see our first blob storage input here. We discussed earlier that there's only 3 types of inputs: Event Hubs, IoT Hubs, and Blob storage for Stream Analytics, but these are really pretty sufficient. When you think about it, the Event Hubs is a high capacity, high throughput journaled event endpoint, which will handle data of all sorts, generally text data though. Blob storage is a large capacity storage service in Azure where you can put data of all types. But for Stream Analytics, we are looking for textual data, either in Parque, Avro formats. JSON, CSV are some of the supported formats that can be read by Stream Analytics. So at this point, we're going to add a new Event Hub input type. We use the prefix in so we can tell these apart when we're writing our queries. This is a type of hubs input. Could be a type of IoT, but I like hubs as the name. And we're going to call this one stats 2. For the event today, I set up an Event Hub namespace and Event Hub. And because of the tight integration that Stream Analytics has with other services, we can already see an Event Hub here for my subscription is up and ready for use. And here's the namespace. Here is the hub that I set up called stats, hence the name stats here. So in order to access your Event Hub, you need to have a Event Hub policy or a access policy. By default, you get a single root managed shared access key policy in your Event Hub's namespace. And for your either at the namespace level or at the Event Hub level, you can create additional access policies. I've created 2 access policies here, one for reading and one for writing. You can see they have claims of send and listen. So for Stream Analytics, we're actually going to be using the reader policy. I'll show you in just a second. We'll use the writer policy to push some events into Event Hub. I want to use an existing here, and I think we can actually just select it from the dropdown. How nice is that integration? We also already have pre-populated the consumer group because I'm running Event Hubs at the basic level. Basic tier, we only have a single consumer group, $ default. We don't need a partition key because we are not partitioning these Event Hub or the Stream Analytics by the partition IDs of the Event Hubs. We'd need to do that if we wanted to have a very large throughput, multiple thousands of events per second in order to require doing that partitioning. So we are going to be using JSON for our events coming into the Event Hub. We'll show you that in just a second. It's a pretty straightforward PowerShell script that's also available in the book and the associated GitHub repository for the book. In Chapter 6, we've got multiple files here representing the the data that we're going to be pumping into our Azure Event Hubs. I've already pulled it out myself earlier and collected it so that we can run some data into Azure. So these data files are open for anybody to access if you want to use that, you want to refer to them, and if you want to use them in addition to the book content here for Azure Data Engineering. Like I said, the code does run. Actually, I can show you the code. I've got it sitting right here. This is the important part. We're building an object array here with 4 fields: player, node, node value, and event time, just like we had for our CSV. And we're going to convert that to a JSON object before we send it off to our Event Hub. The rest of this is building our Event Hub hookups so that we can submit data to that. So we're going to have JSON. It's going to be UTF-8 because use Unicode, and no compression here. You can compress these using gzip, deflate, and that compression and decompression is supported natively during the read process. All right, we're going to set that input up, and all the inputs we do, Stream Analytics does a test first. And we've successfully connected, so that's good. And as talked before, here on the far right of your input, you have the button for sampling data. So before, we have a start date to start the sample from the input end, and then a duration to run the sampling for. We've got 5:14. My local time is 5:18 p.m. So let's set our sample here. Let's give ourselves 10 minutes of sampling and start the sample. All right, what we want to do, we need to copy all of this code and run it in Cloud Shell. Those of you who don't know, Cloud Shell is Azure PowerShell and Bash in the cloud. You log in with your Azure account, and you are automatically connected and authenticated to the Azure environment. And depending on your level of access, you get to do all of the managing and interactions with Azure through PowerShell without having to install it on your local machine, without having to get the Azure PowerShell module installed, and without having to do the authentication in PowerShell on your local machine. So I appreciate it. It updates frequently, and apparently sometimes has a hard time connecting. So let's try restarting this and get a new instance of a Cloud Shell here. All right, now we go. Now we're connecting. All right, there we go. Well, our collection timed out. Let's try that again. At 5:20 for my local time, but let's add 10 minutes on there. 5:17. Run that. We've got this code. Be able to add that in here. Looks like I'm going to have to change my subscription again too, since we didn't connect. Since I have multiple subscriptions, you can see I've got to switch between the primary and secondaries in here. So let's try that again. That looks a lot better. In case you want to know, here's a tip when using Cloud Shell. Shift Insert on a Windows machine is the copy and paste. Control V gives you a ∠V. You can also right click and let's see, you can select and right click and copy, but pasting is a bit more of a challenge. All right, let's see if we capture that again. It's not. Let's try the capture one more time. We left that running. There we go. So we were able to successfully capture that by getting the correct time. And here's the data that we've run in. From our code, we've got a JSON file here. JSON files formatted a little funny here in the window, but I think it's readable. We've got node element value 12, event time value 2020, 6/9, 21, 21, 48. Layer a Bera A101, node value 100.2. And we have several files or several fields that are appended by Event Hubs. This is the event process. This one is appended by Stream Analytics. These are all actually appended by Stream Analytics based on their source. Now we have a partition, because this is from Event Hubs. We've got partition 0 and partition 1, 0-based numbering. And we've got event enqueued UTC time, which is the time that the event made it into Event Hubs. You can see these actually advance time. We've gone several, looks like 3 to 4 items per second in that Azure Cloud Shell PowerShell command. Okay, so that was successful. We had data successfully coming in there. One thing you can see when you look at Event Hubs, the overview blade is data that's been coming in. So we can see we submitted some data here over the this is the last hour. Starting at 5:15, we submitted some rows in here, or some messages into the Event Hubs. We did 82 requests, 82 successful requests. Want to look at the messages. We did, starting here at June 9th, 5:23 p.m., 30 messages coming in, and then 30 messages going out when we did our sample capture. All right, so that input is set up correctly. We'll be able to use it in our query later. Now, so we've got that input set up. Let's add a new output as well. Said earlier we have multiple options for our outputs, including blob storage, which we're using. We can go back to a new event hub to run a different set of data basically into a new event hub. Aggregate data or a subset of the overall data that was coming in from the primary event hub. Run it out to table storage, do service bus queues or topics for distribution to other asynchronous services, Cosmos DB and SQL Data Warehouse or other storage. At this point, we're going to use a SQL database because this is one of the most interesting outputs you can get, in my opinion anyway. So since it's an output, we're going to use prefix out. This is a type of SQL, and we're going to call this stats, because that's what our database is called. So I'm going to switch over to the SQL database that we've got here, player stats. So I guess we'll call this player stats. And as you can see, we've already, because of the tight integration, we have subscription, the database already available here for selection. The table is called raw, and I configured the username, password, and tables earlier. Let's take a look at that. You want to know how I set up a SQL database, SQL Server in Azure. You can refer to both Chapter 6 and Chapter 11 of Azure Data Engineering to learn more about those. All right, we have a table with these fields. I can actually say that we have player tables, or a table called players and a table called raw. 4 fields in it. So we're going to be using that table as our output. We can run data straight from Stream Analytics out to SQL database in near real time. But of course, a single input at a time is less than optimal for high capacity inserts into SQL databases. So Stream Analytics allows you to batch your inserts via a nice background process that Stream Analytics handles for you. This is one of the tweakable items that you may want to test with smaller batches to see what your level of SQL database can handle and what your time responsiveness for your stream analytics job can handle as well. But the default works pretty well in most instances if you don't have a lot of data, or if you've scaled your SQL database up large enough to handle it. All right, the connection to the SQL database was successful. That's gratifying. Now that we've got a new input and a new output, let me show you one interesting thing. I don't know if it's very clear on the video, but having clicked on this input, because we had done a capture before, and we made sure that that worked and we had data, even though this is a sort of a stream and not a file, we still have some data in the background, and we can do a preview of the data. So we can see all the fields that we're going to get here and the data that we captured earlier. So because we're going to use a couple of different, an input and output, then we need to change these values. As you can see, as I'm typing on the left side there in the outputs section, as you put in names that aren't valid, you'll get those indicated in the left-hand column there, so you can tell what's in your query and what's potentially broken. Nope, we're not coming from SQL input, we're coming from a hubs input. One thing, if you recall from looking at the setup of this, is there are only 4 fields listed in this table, but we've got 7 fields listed here. So if we do a pass-through query for this, we'll actually get too many fields coming out. Let me actually take a look at that and see what it looks like. All right, so it looks like this should work. Let's go ahead and save this query. Go back to the Overview tab. And we'll start this job. So because we put some data in at the beginning of 5 p.m. and because we've started this SQL job once before, we now have the option for when last stopped. Say we stopped at about, I think 25. Let's see, we have probably stopped at about 9 minutes after 5. I think that's indicated here. I'm going to set this here so that we'll read from our previous set of data in the Event Hubs. You see in the Event Hubs here, we read out some of the messages here, starting at 5:24 p.m. during the capture phase. So these might not be these would not be read out again if we started at 5:30. But now you can see we've put in 30 messages. Now we've read an additional set of messages here. So we're still starting here. Streaming jobs do take a while to start, typically a couple of minutes. One of the things this process does is compile everything and start to actually run data out to your endpoints. Depending on your query, of course, you actually might not get data written out for a while if you have where clauses, filter clauses, and windowing functions in your query such that you only produce an output at certain periods. All right, so we did successfully start the job, no problems with our outputs, but we now have an alert here next to the SQL player stats output. So we dig into this and we can see an actual helpful message here. See a bit of a helpful message here as well. Let me see if I can move this out of the way. So we have an error trying to write 29 events to table raw. Missing column, event process UTC time. And that shouldn't surprise us because that's one of the things we noted before, was that the table here has only 4 columns. And our hubs input has more than 4 columns. Let's see, go to query, look at hubs. As you can see, we've got event process UTC partition ID and event queued UTC time as fields that are in the select star query. So what we need to do is make sure that we match our query output to our output, which in this case is a SQL table that has 4 fields. So we need to select only those 4 fields. So we're stopping the streaming job, because we can't make any changes to the query or the inputs while the streaming job is running. All right, streaming job has stopped. Let's update our query. And our fields are player node, node value, and event time. All right, so that's our input. Let's see what our output will look like. All right, we can see we've got 4 columns here instead of 7. So let's go back to overview, start the job again. Let's start this again at 5 o'clock p.m. All right, for those of you joining us now, welcome to Manning Publications on Twitch. My name's Richard Nuckolls, and I'm talking about Chapter 6 of Azure Data Engineering, specifically real-time queries with Azure Stream Analytics. We're setting up Azure Stream Analytics inputs, outputs, and query, and doing some troubleshooting when things go wrong and things don't work, and some of the best practices around getting your inputs set up and tested so that you get success from the go. I tell you what, starting and stopping a Stream Analytics job 15 times in a row because you can't figure out what the name of the field that you're supposed to be putting in there to write into a SQL table is fairly frustrating. Because it's not instant to start and to stop. While we're waiting for that to start, you can see here on the overview blade that you've got a couple of monitoring tasks here. Both the CPU utilization, the stream unit utilization, indeed, of your Stream Analytics job. We can see we're running about 14%, which is basically idle. 12 to 14% is idling. Once you start getting above 50%, you can consider scaling your Stream Analytics job up with more streaming units. So we did have a successful start of the job, and unlike last time, we don't have an error indication here on the SQL output. Let's take a look back over here in the SQL database, and now we've got rows in here. $30 in there right now. Let's jump back into Cloud Shell. Let's put another 30 events in here. So if we want to look here in the Event Hub, we can check our metrics. Let's see, we'll use incoming messages. Outgoing messages over the last hour. So you can see we had a little bump here of writes. We had a read here, and then we've had several reads so far. Let's take a look at what the last half hour will bring us. We can do the same thing here for Stream Analytics. We can look at input events. Output events. Runtime errors. Let's limit that as well to the last, look at the last hour. See, we had some outputs here. There, and now we've got a runtime error showing here. Just when we tried to write incorrect set of fields to our SQL database. We had 30 input events here, no outputs. And now we're starting to get some data in here. We've got 30 inputs read, 30 outputs written. That was a few minutes ago. 5:45. And now again, we have 30 and 30 here and 30 and 30 here. Let's refresh this. We had 30 messages in, 30 messages out. So our Stream Analytics read from our Event Hubs. Our Event Hub is read from, or our Stream Analytics is read from the Event Hubs and written out to SQL. So now if we run this again, we should have 60. And there we go. Let me show you one last thing before I head out this evening. If you've just joined us, you're towards the second and final hour of setting up Stream Analytics in Azure. I'm Richard Nuckolls, and welcome to Manning Publications on Twitch. If you're just joining us, this is a stream talking about Chapter 6 of Azure Data Engineering, my book, which is in Manning Early Access program right now, should be out in print in fall this year. So we're going to stop this job. All right, because I'm a little impatient, I'm going to jump in here as quick as I can. All right, last thing I want to show you is how do you run grouping with a window function in Stream Analytics. So if you look at this, you can see group by does not work, and this would be a valid, semi-valid SQL query. We get an answer here of exactly one temporal window is expected. That means we actually need to specify a temporal grouping as well as just the field grouping here. So I'm going to pull up a grouping window here out of some of the snippet of code in the book. This is a tumbling window grouping. This will, every 150 seconds, create a new micro batch of data as a window on the unending set of data that's running through the Stream Analytics. So now we could say, let's test this again. Let's test that again. Let's test it 3 times. All right, so our results are we have a group. All of these were A-Bara. So let's change it to a slightly more interesting set of data. This will be in Blob stats. We've got our in Blob stats, out Blob stats. Let's test that again. All right, now from our input, we can see that we've grouped BBE, ABE, and ABW. We've got a count of each of those. Let's save that query and start our job again. Let's start when last stopped, which we stopped about 5:47 p.m. While waiting for the job to set up, this is temporal windows, and the windows in your Stream Analytics query are covered in depth in Chapter 6. Windows queries. See, we've got 4 different types: tumbling, hopping, sliding, and session windows. And each of these has a different way it groups together messages across time as they flow through your stream. Take a look at Chapter 6 of Azure Data Engineering if you want to learn more about this. You've got the streaming job started. Because I started it just now, it's not going to pick up any of the old blobs in the blob store, so I need to put a new blob in to run through the stream. So we'll switch to our containers, storage account, stats input. We've got 3 of them in here. I'd actually like to add a 4th. Make a quick adjustment on that. All right, now we'll upload that file. And there we go. The new file has flown through the stream and has output the results of our query, which were player and count in a pipe delimited fashion. You've got 4 different players in this data, and there they are grouped. Okay, that covers SQL and Blob inputs and outputs with Event Hubs as well in Stream Analytics. Thank you, everybody who's come along and watched from the beginning. I hope this has been very useful and informative to you. My name is Richard Nuckolls, and if you want more information, you can check manning.com for my book, Azure Data Engineering. And hopefully coming next week, I'll have some videos up on YouTube with more details or going over setting up various resources in Azure as well. All right, that's it for me, signing off.